All right, 2.3. 2.3 is all about rotation. So let's look at the worksheet. Number 2, triangle FGH has vertices F at 2, 2, G at 4, 1, and H at 5, 4. So first, draw triangle FGH, and then draw its image under a rotation of 90 degrees counterclockwise about the origin. Okay, so in this unit, we talked about the different types of degrees of rotation. So we talked about how all of our rotations are always going to be about the origin. And just to keep it real simple, we're going to stick with degrees of terms in 90 degrees. That being that we will only be rotating 90 degrees, 180 degrees, 270, or a full 360. But we also need to keep in mind the direction as well, because a 90 degrees clockwise turn would be different than a 90 degrees counterclockwise turn. So let's look at this problem. So first up, we'll draw our first triangle. Okay, so we have our points F, G, and H. So I listed them right here. So my original triangle is here in blue. And it tells me I need to do a 90 degrees counterclockwise rotation. So just like with the reflections, we had cool little tricks to help us determine the new points very quickly. So with my original point X, Y, I need to flip the coordinates, and then I need to also change the sign on the Y. So I'm going to take my original, flip them, and then change the sign on the original Y. Okay, so F was originally 2, 2. So I'm going to switch the places, which keeps it at 2, 2. And then I'm going to change the sign of the original Y. So my F prime will be now at negative 2, 2, which will be right here. G was originally at 4, 1. So I'm going to switch the 4, 1 and make it 1, 4. And then change the sign of the original Y and make it negative 1, 4. So my G prime will be right here. H started at 5, 4, switch it, make it 4, 5, and then change the sign of the original Y, make it negative 4, 5. So that'll be my H prime. So once I've done that, I connect the dots, make sure to write down my points, and I'm done with that one. So for number 7, we were given figures and we needed to determine what was the order and the magnitude of these figures, okay? So keep in mind, when we're talking about the order, we're talking about rotational symmetry. And the order is the number of times that I can rotate a figure and it look just like its original figure without having to turn it a full 360 degrees. So that's how I can determine what the order is. And then the magnitude is going to be the degree amount that I must turn that figure in order for it to look the same. So right here, we have a six-sided shape, a hexagon. It appears to be a regular hexagon, meaning that all the sides have the same length, all the angles have the same measure. And so if I was to turn this thing, I could turn it 6 times and it would still look the same. So if you wanted to go through and track its turning, what you could do is maybe you just put a tick mark on that top side. Okay? And you start rotating this piece of paper. And so as you rotate it, you watch and you mark where the tick mark's at. So if you were to turn it just a little bit, you would see that now this side right here would be on the top, and the tick mark would now be where this side is originally. And you go around and do that 6 times until your tick mark around the back of the top. So because of that, this hexagon is going to have an order of 6. And then lastly, you want to know what the magnitude is. Again, the magnitude is the degree amount that you have to turn this image for it to have rotational symmetry. And so a quick way to do that is you take 360 degrees and you divide it by the order. So in this case, that would be 6. So when you take 360 divided by 6, and you would get that our magnitude is going to be 60 degrees. All right, so number 10. So number 10, for this one, we are going to be given instructions to do 2 reflections. We're going to do 2 reflections. And then after we've gone through and done those 2 reflections, we need to then name, basically, if we were to do 1 rotation to substitute for these 2 reflections, what would that rotation be? So number 10, triangle DEF with vertices D at 0, 4, E at 2, 3, and F at 1, 2 is reflected first in the y-axis and then in the x-axis. So go through and you will draw in your first triangle. So your original triangle DEF is this triangle right here in blue. So first I need to reflect it in the y-axis. Okay, so remember that little trick with us doing it in the y-axis is just we're keeping the numbers the same and we're going to change the sign of the x. So 0, 4 remains at 0, 4. 2, 3 becomes negative 2, 3. And 1, 2 becomes negative 1, 2. And that's our first reflection. Then we need to go through and reflect in the x-axis. So this time we're going to leave the x alone and we're going to change the sign of the y. So here, 0, 4 became 0, negative 4. Negative 2, 3 became negative 2, negative 3. And negative 1, 2 became negative 1, negative 2. So my second image is going to be this triangle here in red. That's triangle D double prime, E double prime, F double prime. So if we look back to our original, this blue triangle, triangle DEF, and look to our last image, we can see that from our original points, all that happened was the signs of both of them got changed. So XY became negative X, negative Y. And so if we were to put that in terms of a rotation, we know that based off the lesson we went through today, that this would be a 180-degree rotation. If we were to do this basically in one move, in one rotation, rather than do it in two reflections.